Good morning, everyone. My name is Rushabh, and I am from brand CSE AML. I'm going to talk about object-oriented programming. What is object-oriented programming? Object-oriented programming, OOPS, is a programming paradigm that organizes software around objects, which are entities combining data and functions related to that data. Real-world modeling approach. Example of object-oriented programming are Java, C++. Why to use object-oriented programming? OOPS, also known as object-oriented programming, is widely used because it offers major benefits like better code, organization, easier maintenance, and strong support for code reuse. Key advantages: modularity. Object-oriented programming divides program into discrete objects, making code easier to manage, test, and debug. Each part of the software can be developed, maintained separately, which speeds up project's work. Reusability. Through inheritance, developers can use existing code and extend it for new functionalities, reducing redundancy and overall development effort. Maintainability. Encapsulation groups related tasks inside objects and restrict direct access to data, making application easier to fix and upgrade without affecting other parts of the code. Flexibility. Object-oriented programming makes it easy to modify features or add new ones, since change in one class usually do not impact other classes, especially which is good in encapsulation. Easier troubleshooting. Self-contained objects help developers to isolate and resolve issues, improving overall debugging efficiency. Security. Data hiding and abstraction protect code from unintended interference and make it more secure and reliable. Scalability and teamwork. Object-oriented programming allows multiple programmers to work on separate components simultaneously, which is essential for large-scale and complex software projects. Core concepts of OOPS. In object-oriented programming OOPS, the core concepts include classes, object, encapsulation, abstraction, inheritance, and polymorphism. This principle helps structure code to closely model a real-world system and make software development more organized and efficient. Class. A class is a blueprint or a prototype for creating objects, defining shared variable attributes and methods, which are called functions. It contains common properties and behaviors for all objects of that type. For example, a car class can have attributes like color and speed, etc. Object. An object is an individual instance of a class represent real-world entities. Objects contain both data, state, and methods behaviors which allow them to interact with each other. For example, specific cars like Toyota or Honda are objects created from the car class. State. The values or attributes of an object like color or speed define its current state. Behavior. In object-oriented programming, behavior refers to action or operation that an object can perform, which are defined by methods which are known as functions associated with its class. Encapsulation. Encapsulation is a fundamental concept in object-oriented programming that involves bundling of data and the methods that operate on that data into a single unit, usually a class. Encapsulation restricts direct access to a certain component of an object and only allows access through public methods such as getters and setters. This mechanism protects the internal state of an object from unintended or unauthorized modification, providing data security and integrity. For example, consider a car class with a private variable speed and a public method, set speed and get speed, to modify and access the speed. External code cannot directly change the value of speed without using the class's method. Abstraction. Abstraction in object-oriented programming is the concept of hiding complex implementation details and exposing only the necessary features of an object, making working with software similar an object efficient for users and developers. Abstraction allows programmers to define classes that model real-world entities by focusing on essential properties and behaviors while hiding the intricate working and unnecessary details. For example, when driving a car, you can only interact with a steering wheel and pedals, essential features, without knowing how the engine works internally, which is hidden details. Inheritance. Inheritance in Java is a key object-oriented programming feature that allows a new class, subclass or a child class to inherit properties and methods from an existing class, superclass or a parent class. Key extend keyword is used for class inheritance, enabling the reuse and simplifying code maintenance. The subclass automatically acquires the field and the methods of superclass, but it can also define additional members or override the inherited ones. Polymorphism. Polymorphism is a core concept in object-oriented programming, where objects of different classes can be treated through same interface, allowing a same method or function to behave differently depending on object what it acts on. The term polymorphism comes from Greek meaning many forms. It enables one interface or method name to represent different underlying forms like data types or classes. In practice, this means you can write a code that works with a general classes and rely on subclasses object to provide their specific behavior. For example, a parent class shape can have a method draw function. Subclasses like circle, square, and triangle override draw function to store distinct shapes, but in a program you can call draw function on a collection of shape objects and each will respond correctly based on the actual type. Dynamic binding. Dynamic binding in Java, also known as runtime polymorphism, refers to the process where the method to be called is determined at runtime rather than compile time. Dynamic binding is enabled by method overriding with a class hierarchy inheritance. When a subclass overrides a method from its superclass and a superclass reference points to a subclass object, the Java Virtual Machine (JVM) determines which method implementation to invoke at a runtime based on actual object type, not the declared reference type. This mechanism supports flexible and extensible code as the same method can call the result in the different outcomes depending on to the object instance. Advantages of object-oriented programming. Code reusability. Classes and objects can be reused across programs through inheritance, saving development time and reducing redundancy. Modularity. Code is organized into self-contained objects, making it easier to update, debug, and manage different parts of a program independently. Easier troubleshooting. Errors are more easily traced to specific class and objects, making debugging more straightforward. Improved productivity. Modular design, code reuse, and simplified maintenance accelerate development and make teamwork and collaboration easier. Better security. Data hiding and encapsulation protects sensitive information from unintended modification. Real-life example. A banking system is a classical real-life example where object-oriented programming concepts are used to model real-world entities and their interaction. How object-oriented programming concepts map to a banking system. Classes and object. Classes such as bank, account, user, transaction act as a blueprint for object representing bank, individual accounts, customer, and bank transaction. Encapsulation. Account details like balance and account number are kept private and exist only through methods such as deposit function, withdraw function, or check balance function, which ensures data security. Inheritance. Different types of accounts like saving accounts and current accounts inherit common properties and behaviors from a general account class while adding or modifying features as needed. Polymorphism. Method like deposit function or withdraw function can have different implementation in different account types, allowing code to work with various account objects through the same interface. Abstraction. Complex bank operations like loans, interest, calculation, transfers are hidden behind methods and interface. Users only need to call a simple method without knowing the internal logic. Popular language supporting object-oriented programming. Language like Java, Python, C++ supports object-oriented programming. The features object-oriented programming provide to Java are fully object-oriented programming, classes, inheritance, interface, encapsulation. Typical use of Java are enterprises apps and Androids. The features that provides to Python are multi-paradigm, classes, inheritance, encapsulation, dynamic typing. Typical use of Python are data science and scripting, web and machine learning. C++ features are multi-paradigm, classes, inheritance, operator overloading. System software and game making are the typical use of the C++ language. Conclusion. Object-oriented programming provides the foundation for scalable and maintainable software architecture, making it easier to modify, upgrade, and expand application as user needs evolve. By organizing code around objects that reflect real-world entities, it improves clarity, bridges the gap between problem solving and code implementation. Object-oriented programming principles like encapsulation, inheritance, and polymorphism actively support code reuse, faster bug detection, and modular development, resulting in increased productivity and fewer errors. Thank you.